1/2 of our vector PQ, well, if we write down 1/2 of the quantity 5i plus 2j and use the distributive law treating I and j simply as constants. We know they're vectors, but they can be treated as constants. We get 5 I plus j. Now this vector has a I component that's half as great as the PQ vector, has a j component that's half as great as that of the PQ vector, so that this vector is in the same direction but with half the magnitude. We'll say half the length, or I'll abbreviate it MAG for magnitude. Okay, now if we take the vector PQ and divide it by the magnitude of PQ, what do we get? We get 5i plus 2j divided by the magnitude, which is the square root of 29. Now that's 5 divided by the square root of 29i plus 2 divided by the square root of 29 times j. This, of course, can be put into more standard form, 5 square root of 29 over 29 and so forth. We'll say that's approximately equal to, something like 0.9i plus 0.4j. Now these numbers, 0.9 and 0.4, are only written to one significant figure. You could easily calculate these numbers with a calculator. The point, though, is if we calculate the magnitude of this vector, now this vector, not this one, if we calculate the magnitude of this one, we're going to square the 0.9 to get 0.81, we're going to square the 0.4 to get 0.16, and we add those, we're going to get 0.97, which is pretty close to 1, but not exactly. If we add these components, we're going to get exactly 1. You can do that. If we square these components and add them, we get exactly 1, the square root of which is 1, meaning that this vector is a vector of magnitude 1, which we call a unit vector. Now we're going to see that unit vectors are very handy things. They allow us to specify directions without having to specify angles.